gentlemen, this is spicy unit that we bought from Steve Morris Race Engines. Steve Morris makes the best drag and drive engines on the planet. As you know, they've been fives with a street car and Tom Day's car. No one else has done that. So I guarantee you, we got the best of the best now.
Bad unit alert right there.
Oh my God!
We're gonna find out what happens to our 3,000 horsepower El Camino when we install the world's longest turbo kit. Look at this puppy. She goes all the way out and around the shop and back to the El Camino. We're gonna see if these 98mm turbos can still spool up. If you were to, you know, say out loud, how hot is too hot for an EGT?
What fuel?
Methanol.
The normal would be like 1,050 to 1,300 on the high side.
The high side.
So what if one of your customers got them up to like 1,700?
It's burned up. It's burned up junk.
Well, here's the deal. Here's the situation. I put a 300-foot charge pipe on my El Camino. And, you know, on the dyno, it was taking a while to spool. And then all of a sudden, it was shooting a candle out of the exhaust. So I lifted. But it still runs totally fine. So I just wanted to get your opinion.
All right, it's back. Let's get this thing uncrated. Check it out. In general, this is a bad idea to send me loose lines. Good way of getting stuff lost, Cameron. But I'll make sure that we put everything back in the box. Tell you what. These are 1/2-inch bolts, so they're probably torqued to like 105 with the red Loctite. That's why they're all on there. If this would have taken, this is a bad little mother trucker, but if it would have taken it off, I would have been impressed. We need the big one over there, cordless. All right, now we're cooking. All right. Let's back this up, move the toolbox out of the way. Alrighty, so this is the block that in the last video that we did the clearancing on with the 4-axis machine, trying to show something really neat and kind of cool. And I said to you, if somebody asks a really good question, leave it here in the comment section. I'm gonna read through comments, and as soon as I see a comment that or question that's like, oh, that's a really good question, I'm gonna answer the question name you by name, and send you something really cool out of the merch store. Super good. We're going to keep on doing that whole thing. So let's read some of the questions. There was a bunch of good questions, so we're actually going to read 4, but I'm still only going to select one that we're going to send a bunch of stuff to.
All right, so Gameplay 3D asks, can you not take some off the rod so you don't have to take so much out of the block? Maybe even shave a bit off the bolt.
No. Shaving this rod bolt is one of the most notoriously bad ideas ever. This is cosmetic. It has no bearing on block strength, has no bearing on anything. This clearance groove right here means absolutely nothing. This bolt right here means absolutely everything.
I've seen that a lot, taking engines apart, where people...
Yes, people will just grind on this bolt or grind on, grind here or there. There are some certain areas right up through here, which we'll answer in the next question, but I would never touch the bolt. I would also never shorten the bolt. There's some egghead engineer that has figured out a lot of stuff on this connecting rod. That ain't me. All I know is from experience, don't get the wrong ones and don't screw it up. Don't touch it. Don't touch it. Okay, next question.
This guy said, what about the camshaft? Do you need to reduce the base circle?
Yes, you do. So this already has a reduced base circle camshaft. This is a 900 base circle camshaft because the connecting rod goes whoop, right up close to it through the stroke. So, good question. Yes, you do.
Donut roller.
Donut roller. He rolls donuts for a living, I think.
Yeah, maybe.
I don't know.
What kind of donuts?
I don't know.
Why not go to a Honda rod journal size to aid in clearance?
Okay, so I want to take you back to what we call overlap. So overlap, you want to grab that crankshaft real quick, Joe? Stand up on end. Overlap is this dimension right here. How much this journal overlaps the main, because this is where all your strength is. If we make this pin smaller by putting a Honda pin on here, so what somebody's talking about, if you don't know what he's talking about, is you would do a Honda pin journal up here, which is a small diameter. So you make this really small, which would make the big end of the connecting rod smaller. Problem is, it's weaker. We're not building some NA comp eliminator engine or something like that that needs to make less than 1,000 horsepower. We're building something that needs to make more horsepower. As a matter of fact, let me show you this super quick. So these are stacks of SMX cranks and SMX or SML crankshafts. Now this is a Windbird SML crank, and we've done the exact opposite of what you just said. So what is getting to be common and a really good thing to do for maximum strength is Cleveland, Maine for the SML or LS. Cleveland, Maine, big block Chevrolet connecting rod journal. So it's actually bigger journal. This is a 200 journal instead of a standard 100 journal. What does that do? Puts more material in this overlap area, makes the crankshaft stronger. Okay, so let's go back to the other questions. All right, next question.
Oh, okay. Craig Forbes, 7185. Steve, we would like to know more about your employees, why they love working for you, and why are they in the engine building line of work?
Well, since you're an employee, you could probably answer that, but I'll answer the first part. I'm an astoundingly kind, generous person that people just love. I'm very likable.
Yeah, you definitely, yeah.
So Joe, why do you love working for me?
You're quite literally getting paid to say this. Steve actually really is honestly a great person to work for. And I do love working here because I learn a ton. And I told Steve when I started working here, I'm a forever student in this industry. So I truly believe that you never stop learning in this industry with building engines, building race cars. It's just a constant learning experience. And it's a lot of fun to do. Building engines, I think it's kind of somewhat of an illness.
It is
You got to be
an illness.
you got to be a little bit crazy to want to do it. for a living because it can be very stressful.
Yeah.
Kick you down a lot,
Yeah.
you know.
Yeah.
But you got to really love it. But if you love it, it's the greatest job ever.
There you go. So in short, I'm the greatest boss ever, and this is the greatest job ever.
Correct. What Steve said.
Yeah, there you go. All right. So I think my favorite question out of there, outside of that one, my favorite question is on the Honda pin, because that's a pretty legit, well thought out question.
like
And
that one,
but here's the deal. I'm not gonna hunt you down to find you so I can give you stuff. You need to contact me. So just shoot me an email, sales at Steve Morris Engines, and I'm going to send you a super cool care package. Now, back over to Cleetus's engine. Let's get this thing torn apart, and we're going to do the same exact thing. If you see something you got a question about, ask a question. I'm going to go through it, read questions, comments, and when I see the very first question I see, they're like, oh, that's really good. That could be you. All right, you very well may have a son that works with you, and you quite often go, where is my mother freaking 9/16 wrench? Automatically assume it's Kyle, because 99% of the time it's freaking Kyle. So anyways, let's get this thing tore apart. So what I'm gonna do here is we're just gonna do some time lapse, and then I'm gonna stop in and talk to you, show you stuff. Time lapse, stop in, talk to you. So don't just think all this is time lapse and just blare your way through. So had to get the valve covers off just in order to get the connectors off the fuel injectors because they're so goddamn close, which is normal. That's no big deal. And then so that wiring harness, this wiring harness goes, oh, there's coolant temp, okay. So coolant temp on this one, and then goes to the Rife sensor. And then this is the main injector harness, and then the drive injector harness, because on my intake manifolds, the third set of injectors is down below. So I will go put this in the box. I see that they have made some alterations from the last time I was in this motor, and looks like tie welding right through here, really good, and it mounted some stuff. So, so I'm just trying to make sure that I want to have it put back together, at least within reason to what Cameron sent it to us as, just to save them time. I don't like causing people hassle. So all this stuff is going to go back over to there. We'll get all this stuff. We'll put this all in the crate so I don't lose any of it, and get rocking here. So take this stuff off. Leave this on. Fuel pump. It's a big bad boy Aeromotive fuel pump here. Probably should be a 20, usually 21 to 24 gallon per minute pump here. And it's drive mandrel, all this stuff. First thing you see here is, so we got the intake manifold off. With these intake manifolds, we have a revision coming up that is going to be exclusive to Steve Morris Engines, is where it's like, I got to do this revision right in this area right here, because this is a mother, because you have to put it all together with this in there and take it apart with all this in there. So it's kind of a bugger. So we're going to modify this intake here. I won't be able to get that done for Cleetus here. I mean, once everything's in, it's fine. It's just a little hassle putting it together and taking it apart. But we're going to pressurize this thing and verify and pressurize it for leaks, pressurize the crankcase to make sure there's no air leaks, no oil leaks, nothing, so we don't have to deal with this, because this little thing here is notoriously kind of a leaker, or can be, especially if you end up having to come in here and move this and break the original silicone seal on it. It does that. So we're going to, I'm going to do a couple little updates that I can do here. Fix a couple little things here on the intake manifold where the bolts are going through, just to make it nicer. But so the whole issue here is I laugh because it is what it is. This is the way Cleetus works, right? And it's all cool. It's his stuff. He can do whatever he wants to with it. And so when he did that whole, 300 foot of charge pipe on it, which I even thought was interesting, and I laughed when he told me what he was doing, because he understands, hey, it probably could hurt something. So we're going to find out. So what is the major issue? All the heat. That very long duration, like right here, where Cleetus is, and what the engine is doing, the engine is trying to go. It is not making any boost. The only thing it is doing is making a lot of back pressure, a lot of temperature in the exhaust. So when it is 1700 some odd degrees in the exhaust port out here, how hot do you think the temperature is in the chamber, on the valves, in the exhaust port, all that kind of stuff? So on top of the piston. So that's what we're going to see. How hot did stuff get? Did it do any damage? Did it not do any damage? What kind of stuff do we need to fix, repair, look at? So that's what we're doing here. Now that we got this to a basic long block, I'll start taking off valve train, but I also want to go through and I will actually do a little cold lash on this, just see where the rocker arm lash is right now, just to see where they're at and make sure everything's good. And then we can notice when we lash these things. So I'm going to do this very specifically. We do it one cylinder at a time. I'm going to roll the cylinder up on top dead center. Just do a quick lash, just make sure that they're within reason. Nothing's like super loose, nothing, something like that. Then take the shaft off. Do not loosen these adjuster nuts. Do not. Don't be lazy. Roll the thing over until it's at a good spot, till there's a little bit of lash on both rocker arms. Then take the rocker arms off. Then go to the next cylinder. Check them. See where they're at. See if there's anything going on. So we can diagnose this properly to see if anything's moving, changing, shifting. Because things move, change, shift all the time. All the time. So let's we'll just get a socket on here. We'll roll this thing over. Should be able to roll it over on that. We'll take all the spark plugs out. Start doing a real good analysis. First is on the valve train. We'll get that all off. Look at lifters, see if it hurt anything there. Then we'll look at to get the cylinder heads off. I think we'll end up tearing the whole entire engine apart, looking at everything there. Then we'll come in and tear the cylinder heads apart. Look at valves, look at springs, retainers, keepers, look at everything. Honestly, I'm probably just going to replace a bunch of stuff in this just because it ain't worth it. It can be perfectly good, measure absolutely perfect, look like it was brand new out of the box, and fail the next pass. Of course, a brand new one can take it brand new one out of the box, put a valve in, a lifter, a push rod, a connecting rod, a piston, anything, doesn't matter what it is. It can be brand new, the best money can buy, and it fails. That's what racing is. It is what it is. So let's we'll get these rocker arms off, and if I see anything, I'll stop the camera and show you what we got going on. Nate, the camera guy, just made a really good point about what I was just talking about there. With it could be brand new out of the box and just fail. You ever heard of any of the big three or any automotive manufacturer doing a recall? That's weird. Hundreds of millions of dollars to develop these things. Hundreds, if not thousands, of engineers going over everything. These things have been tested and tested. And there's a recall because something fails. Just one of them things. So that's always something to think about, and that's one of those things I'm really trying to explain to people. This is no excuses. This is just the way things are, the way things work. If this was your mom's Toyota Camry, it still probably has a freaking recall on it. They're probably still fixing something, but if it was, you probably wouldn't have to worry about any of these things. So that horsepower to destruction curve, top fuel, we're going to rebuild this every single 4 seconds. 3.5, whatever. Okay? Every 4 seconds, this thing has to be rebuilt. So that's 12,000 horsepower. Your Toyota Camry is 150, 200, whatever it is. I don't know. I don't have one. Basically, it wears out over time. I don't know, a couple 100,000 miles, whatever. Okay? So every engine, so here's the linear line. It just goes up. It's an exponential line of 4 seconds, a couple 100,000 miles. Every engine, as it increases in horsepower, gets closer and closer and closer to that one. All right, so all of the rockers were lashed correctly. It still had an accurate lash, except one right here. So this number 8 intake was loose, not excessively, but probably about 20 compared to about 5,000, so about 15 thousandths looser. So I checked the rocker arm. I checked every rocker arm when it came off, felt the tip, felt the bearing. Everything feels good there. The only reason anything would ever get looser, that's not a valve problem. So if a valve is failing, the lash gets tighter, not looser. Okay, think about it. Got it. Okay, push rod is good, rocker arm is good, everything is good there. So we're going to check this lifter and feel that. And if the lifter is good, then it would just be, improperly lashed. If the lifter's bad, then we just found something and something got hurt, okay? Push rod's good, everything's fine. The wheel is, here you go. The wheel is really nice. It is, that thing is really good. There is no problem with that. Now these are a diamond-like coated lifter that I had put in there. Really nice, good piece. One valve lash was just out of adjustment. Not a big deal. It wasn't so far off it's going to hurt anything or do anything. But it's just something that we're looking for when we're trying to diagnose stuff like this. And given that all the lash was good, all of the adjusters looked about the same spot, then we'll go ahead and just verify these lifters feel good and then start moving towards taking heads off. Alrighty, so we'll get this head off. We're gonna look at these head gaskets as the first thing we're gonna look at, see what they look like. I'll explain some stuff there to you. Now back onto that one valve that was, obviously, since nothing was worn, nothing moved, the camshaft is no wear on it. There's nothing going on there. It was just a simple thing of, and Zach does a fantastic job of maintenance and engines. Just one maybe got missed or misadjusted or whatever, and it was not a lot. I mean, it was a grand total of about 15 thousandths or so. So it's nothing. So just to clarify, it's no big deal. I mean, so if you're, think that somebody's never misadjusted, never made a mistake, never forgot something, never got busy talking to somebody and flashed it wrong, then you're just wrong. Then you'd have to be lying if you never said you've never done that, never gone back over your race car and go, oh crud, this one bolt's loose. Why is that one bolt loose? Because somebody forgot to tighten it. Or it changed. One or the other. If it didn't change, must be just got, didn't get tightened up right. It's all right. It's all cool. Things happen. We'll take this off and I want to take a look at these head gaskets. The first head looks good. I haven't even really looked at it that much. Now another thing you might be asking is, because it doesn't look like this has any broken valve springs or anything like that. So far, we'll go over things. And in general, this engine hasn't had any kind of problems. But this kind of engine has a totally different valve train, totally different camshaft, and needs a totally different camshaft and profile than, say, SMX or something like that, or the big Hemis or something like that. As they, remember, the horsepower to destruction ratio, limited. It has been tuned perfectly by Pete, done a great job. It's making great passes. Tapped out for where it's at, for where the car's at, everything there. It's just, that's where she's at, okay? So to get to that next level, the level of destruction has climbed up in order to make that same amount, or to next level of horsepower. And sometimes in order to make that next level of horsepower, even when you're not making the horsepower, it still is going through all the functions and the movements to make that kind of horsepower. So for example, let's say for example, it's hot fuel is not quite the perfect example. Maybe a NH or a Pro Stock, okay? Those engines are not designed to run long distances. No different than, they're just not. So even if you just drove that thing, because they do have water in them. So if you just drove that NH Pro Stock engine for 10 miles down to the gas station, it still has to go through all the same valve motion, slower, but same valve motion. Stuff is moving, stuff is going. It is run time versus cycle, cycle time, run time, movement. It's moving, okay? So a lot of times those things will just break just because that's the way they are. So I would be willing to bet that you would see that. Now, the one thing that I do notice here, oh no, that looks good. Everything looks good on these. Now this has a titanium intake valve, incanal exhaust valve, which is good. Which is good. Incanal exhaust valves are the highest heat valve. If it had a titanium valve, similar to, or titanium valve like Bailey's SMX, which just broke a valve, just flat out broke a valve. That's on Thursday's video if you want to come see that, because I fixed the chamber. It's fantastic. Anyways, going through that thing, that's titanium exhaust valves, so they are not as tolerant to heat as a high heat incanal exhaust valve. Okay, so keep that in mind. But you have all this math and all this stuff that plays in part with length of valve, weight of valve. Can we use that valve in like an SMX engine or a Big Chief engine, or even Hemi engine stuff? Typically not. So there's a lot of little math stuff that needs to go along with it. All right, so, all right. First thing, let's look at these head gaskets. Really quite good. I don't see anything here. I don't see anything. A little bit of rust, but that's just because the last thing this thing ran on was methanol, obviously. But head gaskets look good, sealed. I have my top fuel hoops, my SMX hoops, I call them. And Fire ring receiver grooved. Looks nice, looks nice. Over on this side. Now this has gone, I think this went back and at World Cup this year, Jimmy was driving it, and I think it went a new personal best for this engine. And then, you know, they had the playing around slash doing experiments with I think he called himself Dr. Cleetus, didn't he? Scientist Cleetus, Dr. Cleetus.
Dr. Cleet.
Dr. Cleet, yeah.
Yeah.
Dr. Cleet was running some experiments. So anyways, that looks good. Pistons look good here. Gaskets look great. So that's no problem. So now let's look at cylinder heads. Since the last thing this ran on was methanol, hasn't actually run on gasoline. Not really, as far as like street driving kind of stuff, for probably quite a while. They haven't done anything with this one. So this obviously is looking good. Everything's nice here. Combustion chambers look good. That's nice, 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 nice. You can tell by the color of the exhaust valves that they're not a not a titanium, that they're a Inconel. And everything looks great. If I didn't know that they have been abused a little bit with super high heat, even it's on the outside edge of where it really should be, even on Inconel. You'd never know it, and you probably would just like freshen this up. If Cleet hadn't told me exactly what had gone on, I probably would look at this thing, measure everything, go through everything, go, yeah, man, it looks like $1 million, not knowing what had happened. And I would just normally have put these valves back in if they were measured up right, everything was good. I wouldn't known that they went through any kind of extra abuse, right? So, but now that I do know that, I'm going to be changing valves just as a matter of safety. But so everything looks good there. I think we will go through, and after we get the engine the rest of the way apart, we'll come over and we'll take these apart, look at valve job, look at the valves. We'll run the springs across the spring dyno. Now, because back to like a valve train dynamics, the dynamics of how the valve train is, it's a rocker arm weight, valve weight, which is dictated by how long the valve is, how big the valve is, mandates what valve spring we can run on. So this is a different valve spring. This valve spring would not, this wouldn't be able to go do a burnout in Eagle. If Zach put, or Cleetus had Zach put that valve spring on Eagle engine, it wouldn't make it to, it might not even make it to the burnout box. I guarantee it would not do the burnout. I guarantee it would break something, because that valve spring is not capable of running in that application. So, but in this, it's great. Works great. But we'll put them across the spring dyno. We'll check that stuff out. And so let's start tearing this the rest of the way apart before we do that. Looks really good. All right, so now looking at the head gasket, you can see receiver grooves in the block. The hoops go in the cylinder head, so it's pushing down through here. I do lots of videos showing that. Now, why is this whole head gasket so much better than an LS? Okay, why? Because 1, 2, 3, 4, 5, 6 bolts per that cylinder. Then this cylinder shares the bolt pattern too. So this one is a little bit smaller bolt, but not excessively so. This is a, because this will torque up at 65. These will torque up at 80 to 85. But that bolt hole pattern there, not having just 4 bolts out here like what any LS that takes a conventional style head gasket. As a matter of fact, any LS outside of my SML has the conventional head bolt pattern. And when you lean on them, and you're really leaning on them to go super fast, they have head gasket problems. They just do. They just do. Not every pass, not every time. Maybe yours is the Mother Mary miracle. It never's had a head gasket problem. I don't know. But It is very common, extremely common, and they just do because it's just simple math. So why does this big block so much better? Because it has more head bolts and they're more symmetrical. They're closer. So for example, an LS actually would be a head bolt, and this one right here would be like right about where my finger is if this was a LS. But you see, these are closer. This isn't even there on an LS. This isn't there on an LS. These are closer, so it's a much more symmetrical pattern, just like what we do on the SMXs and the SMLs. Alrighty, so I got the oil pan off. Now, I like taking the oil pan off while it's right side up. I don't like tipping the motor over because you saw it. Look down there, the mess I got. If you roll this motor over, I do this at every single engine we tear apart. I always take the oil pan off while it's down like that because it's holding oil. You roll this thing over and it just fills every piston and rod up with oil. And then you take it out and it's just draining all over the place. So I keep it clean, plus I keep all contaminants down in the pan so I can look at the pan and see what's in there without, contaminating and putting all the oil up into the pistons, basically. So everything looks good there. Oh, we've got one little sliver of material right there in the pickup tube. It's a weird one. Not sure what that is. Very small little thing, not sure. We'll put that right there. I'll look at that later. Not sure what that is. Obviously, everything down here looks good so far. I'm gonna clean up all this oil mess down below, and then we'll start taking out some pistons and rods. Looking at the pistons, looking at the rings. The rings take a lot of heat when you do what Dr. Cleet did there. So piston skirts, a lot of stuff. So we're gonna go through this and really take a good look at everything that's going on with it. Make sure that we're all good. There we go. Oil pump drive shaft. A little interesting thing to note is that these rod bolts actually torque more than what the main studs do.
Why is that?
It is a quality of bolt thing. So this little 7/16 rod bolt, this one torques at, let's see, it's at a L19. So these rod bolts here torque to 105. Actually, I think it torques about the same. But that little bolt right there torques the same as that 1/2 inch main stud. Slightly more. All right. That looks real nice. Real nice. Crankshaft looks good. All right, that looks real good. Now I had a customer that just came in here, Sean Skipper, just came in, and we were freshening up his engine, and he wanted to tear it apart and look at it himself, so he did. That's over there. And here, before we look at these rings and stuff, I'll tell you a little story. So he goes looking at bearings and look almost exactly like this because he has the exact same engine as this, basically. And he goes, oh, it says, yeah, what about that color? I go, well, that's the color they are. He goes, I thought bearings were all shiny. No, they are not. Let me show you. Let me come right back. All right, so this is a brand new bearing, right out of the box, race bearing. That is not shiny, is it? In fact, if this Here, I'll sacrifice the bearing. All right. Let's see here. Guess my fingernail isn't quite as tough as I thought it was going to be. Here, we'll just kind of hit it with this plastic handle a little bit, see if that does anything. Well, I'm kind of screwing myself on that whole deal. I thought I could kind of scrape it with my fingernail and show you what it would look like if it was all scraped up. Similar to that. So there you go. That is brand new compared to used. So when I say that looks like a really good thing, you sometimes some of you guys might that just don't know or haven't seen it yet would go, that bearing doesn't look very good, because you think it's going to be shiny and like, ooh, perfect, No, it looks like that. That's brand new. That little shiny that you guys are seeing sometimes. See, there's the other bearing. And you saw this one in particular had a bunch of bluing on it. In fact, that both bearings don't even look the same. But that's just the way they're manufactured, how it works. That is what it is. Okay, this is me touching it, doing all that other stuff. I kind of look at the color of the bearing, and maybe you thought that, or some people probably have thought that they see, oh, look at that, it's turning color. It turned color from brand new. So, just FYI, it's just interesting to note. So that bearing looks really good. That's just normal little scratches in it, just very minimal. That's no big deal at all. So let's look at our rod. Looks great. Nothing there. Bearing looks great. Now these rods really are not going to have any kind of problem. They really didn't care about the heat. The heat would never transfer down that much. The pin is nice. The skirts are, it's not bad. This was this is a line-to-line coating on here, because we had put line-to-line coating on these before we sent this the last time I went through it for Cleetus. So that looks nice, and it's pretty normal. Nothing elaborate. It's worn through the coating where it needed to wear through the coating at. That's exactly what it does. If there's put coating on there, and if it goes through it, it's going to do exactly that. So that looks pretty decent. Our ring is not collapsed here. Our second ring is not collapsed and is not worn all the way across. I don't think it does not look too bad. That doesn't look like any kind of big deal. Okay. That looks good. Let's just keep on going. We'll take them out, look at them one at a time. Okay. Heck, that bearing even looks better. That looks great. If I wipe that bearing, let's see what this looks like if I just wipe it with a rag. There you go. Brand new. Brand old. Used. All right, that looks good. Ring looks good. We're not going to reuse these rings. Now, this ring is definitely worn all the way across, but it's not collapsed or damaged, and feels good and tight. So I don't feel bad about any of that. Let's just keep on going. All right, bearings on all 8 bearings, rod bearings, looking great. Looks real nice. Pistons look good. Skirts don't seem to have any wear problems. Let me look at this one though real quick, because I did notice, or have noticed, on the rest of these pistons that, so this piston, it's a little, I don't know if you could be able to see it from the camera, but this piston, the ring gaps are good, which means it's not getting killed heat wise. That's fine. But I think what we see here on the second ring and on the top ring is a couple of them have excessive wear. So this number 8 looks good. This number 7 looks really good, like what I would expect it to look like. This looks a little more worn than normal. This number 7 is a little, the second ring looks great, the top ring's a little questionable. Then this ring here on number 6 looks great, no problem at all. Top ring looks good, everybody looks happy. And then this one looks pretty good. What I'm looking for is that ring worn all the way across the face? This one is about 3/4, almost all the way. So this is questionable, but not bad. It doesn't matter because I'm going to replace them, but we're just looking for any kind of things. Now this one is worn all the way across. This is number 4, and it's worn all the way across. And I'll talk to you about what worn all the way across means in general. Top ring's a little picked on. This is worn all the way across. So that would be 3. And 1 is, top ring looks good. Second ring is okay, a little more than I'd like to see. And then yeah, this number number 2 here is worn all the way across, and top ring is a little worn. Usually what that would be coming from is, I think those cylinders there where it's worn all the way across just have a little more fuel in them than the other cylinders. We hone these blocks on computer diamond hone, Rattler, I mean super Billy Bad Boy hone. The cylinders are consistent, no doubt about it. So it's not like it's a ring fit or surface finish issue. That is really good over there. So I think there's just a few cylinders that are just a little richer than others. There's no damage in that. There's none. They're just gonna be making mental note and just say, hey, just FYI, this is what I found. That's all we're doing. It's just, this is what we found. All right, so I think everything looks good there. Got that. Everybody's good here. Crankshaft looks good. Let's check thrust and see what we're at. Oh. Boy. Okay. So, again, you can see it back here probably the best. That looks like it's probably about 30 or so. Well, truck. All right. So definitely the thrust bearing is out of it. We'll pull this cap off here in a second. I'll show it. I'll put an indicator on here and we'll measure it exactly and I'll show you. Looks like it's about 30. All right, let's see what we got here. That is there. I was a little off. 20. So 20 thousandths.
And it's supposed to be
7 to 10, right around there is what I normally set them up at. So let's take this off and take a look at it. Yeah, we usually would never set them up at that loose. Let's look inside the oil pan. Maybe this is where that one sliver of metal came from. Ah. Now that we let this drain some more out of the way, I see some material down there. Okay. So, yeehaw, and there's no material up in here, just on that very back, which would make sense. All right, let's take that off. Let's see what we got. All right, so again, we got the color on the bearing, and don't worry about the color. This all looks pretty darn normal. So I mean, this is just, that's the natural color of it. A little bit of wear there, and that is mainly because that's untouched bearing on the front, because nothing is forcing the crankshaft backwards. Okay, if it was forcing the crankshaft backwards, the crank would hit this bearing, and if it pushed too hard, it would wear through it. So let's take the bearing out. I can see it already, and yeah, so shoot. So what that has done is that has beaten that all the way out. Now, I got a couple different options here. One is a brand new option. That's what it's supposed to look like. Now, the way they work this is that there's no way, nothing here can build or hold any oil pressure. It's too small. Okay. Some people try putting drill a little hole right there and make it squirt oil on it. Can't hurt, but really doesn't help because it doesn't have anything to hold it there. These are actually little oil grooves that are supposed to get oil into it and then keep oil on the bearing. Obviously not enough oil there, because you can see it's just foobarred up, destroyed. All right, so a brand new thing that we just found out about, and let's put some heat in the crank, and if you kept going with this and just going and going, this will just keep getting destroyed. Okay, so let's cover why it gets destroyed. And if somebody out there can give me a real educated assessment of what can make that crankshaft, if this engine is just running right here, what makes the crankshaft go forward or backwards? What would make this crankshaft move forward or backwards? There's nothing that makes the crankshaft drive forward that would hit this, or drive backwards, unless there's something outside source that is causing it to happen. Now, if there's something that somebody knows differently than I do, man, let me know. But every time we ever see this, this is caused by something. Something is still going on with whatever's on the back of the motor. That's all I'll tell you. But this is such a common problem. This is a common problem, period. Okay? Typically caused by charge pressure, converter charge pressure. Put too much pressure in the converter and it pushes the converter forward. The engineers at General Motors this bearing design is 50 years old. Okay? Never engineered this to have much more than 150 pounds of force forward, PSI forward. Okay, now don't get hung up on that number too much. It's just a lot of force forward at RPM, at all these other things. So there's something going on there. We've continued to have this kind of problem. Anyways, this is such a common problem that Cleetus Bearing, who's one of the biggest manufacturers in the world of bearings, they are the OG, the original bearing company, one of the original bearing companies. They have, I saw at the PRI show, and they were real big on it and said, hey, we got a new bearing we want to show you, Steve. And I go, oh, cool, what do you got? And for big block Chevrolet and for LS's, they have a, what they've done is they, on a very not visual level, you can't look at it and see any difference in it, but they have changed this whole setup that they have made a taper in it. And what they've done is they've machined like this, the stepped taper in it that makes a hydrodynamic wedge of oil. It actually pulls the oil in to the bigger gap and then forces it into this small taper and actually pulls the oil in and actually pressurizes the oil right there. Pressurize is probably the wrong word. These little stock grooves right here, they just rely on oil going there, and it's the same dimension here as here. Everything's exactly the same. Now they have made the special bearing that is now tapered and makes a hydrodynamic, I think that's right phrasing, hydrodynamic wedge. It's a wedge of oil, okay? Wedge of oil in these 4 spots along the bearing, specifically because the bearing companies know that there is a problem with this in turbo cars. Turbo cars and other cars, but mainly in turbo cars. We're either going, I'm definitely going to put that bearing in there. It hasn't, well, I would do that, but I guess that's just good information for you, but this has screwed up the crank right here. So, so what I'm going to do is we are going to machine and build a roller bearing, thrust roller bearing assembly in the front of the crankshaft. If you'd like to see that, maybe I'll show that and I'll show you how we're working on that. But it basically is machining and building a whole Torrington bearing setup in here, because when the converter forces the crankshaft forward, it rides on that roller bearing, which is oiled. It's a roller bearing. It can accept a whole lot more load than a bearing that cannot have any pressure fed oil, except for maybe this brand new bearing. But since the crankshaft is ruined, I can't use it. Not ruined, it's just worn. Just this one spot is worn. You saw the bearing right here. The journal, everything looks great. It's just that this has worn too much, and there's no real fixing that. You could put a bearing in it, and now this is just going to eat up any bearing we put in it, regardless of what the bearing is. It's just going to eat it up. So no big deal. I'm just going to upgrade Cleetus into a big rollerized bearing right here, and go from there. So that's what we see there. I can see there's everything looks real good in the camshaft and everything. Lifters were great. Everything was good there. That appears to be the only issue I can find. I think that we got the pistons look good. Crankshaft is good, except for that thrust right there. So that's fine. I think we're just going to have to put a rollerized thrust in it. Now, the last thing we're going to check is the valve job and springs and these valves, because they got the most amount of heat. So we see everything that's going on here. We got a plan to fix it. No big deal. It'll be great. Still got to really watch this, how much charge pressure is all there, or what is going on that's making it happen. Whether it's the lockup converter, I'd like to have a lot of information on that too. Comments, questions. Lockup converter. The lockup converter is activated by pressure going into the converter that forces the clutch plates together. So if you had to imagine, you had to, in order to get these clutch plates to go together against the spring, you had to pump up a bunch of pressure in that converter and push it forward. Because it's the pressure going forward that locks up the plates. Now, if somebody can explain it to me differently, more than happy to listen. But there's pressure going in, and it has to keep pressure in it, in the converter, pushing it forward to literally push the clutches closed. There's somebody smarter out there than me on it, guarantee it. So let's tear these heads apart and check those out real quick. All right, try to get some of this stuff out of the way so we can take the heads apart right there.
So is there any reason you would use aluminum rods over, say, steel rods?
Good question. All right, let me show you something here. This is...
Other than the fact that they look really cool.
They look shiny and cool.
Yeah.
Yeah. This is the same rod as what's in Cleetus's engine. Exact same rod. Okay. Yes. There's a couple reasons why we use aluminum rods in here. First reason is that notice how thick this cross-sectional beam area is. Okay. All this big girth, if we duplicated that in steel, this in steel would be astronomically heavy. Why don't you just use titanium? I'll answer that in a second. This, we need the cross-sectional area because as the piston is pushing down on here like this, okay, this is why almost all of the, all but one, maybe two engines I have in this horsepower level all have aluminum rods. The two engines I have out there that have a steel rod were a custom steel rod I had engineering, tried figuring out, not available. You can't buy it because they don't make it for production. I had them made, but they're they're a little harder on parts. Let me explain. So we need, if you just had a steel rod that would be similar strength to this, it'd be much smaller, much smaller. And when you get big horsepower, big stuff, this beam tends to go bend. So a steel rod in big horsepower methanol applications tends to bend. They just do. We've been doing this for a lot of years, and that's just the way it is. Okay. The second thing is this aluminum connecting rod right here. This is on a microscopic level or whatever you want to call it. Running dynamic level is a shock absorber. Aluminum is a shock absorber. Titanium, yes, we can make it light. Yes, we can get the cross-sectional area in it. It would be stronger than aluminum rod, which is the problem. It's actually stronger than the aluminum rod. It has no absorption qualities in it. We need to have some absorption. Can't say it. Absorbing quality in the rod. This is a little shock absorber. Aluminum rod is a little shock absorber. Will it last as long as a steel rod? Nope. Do they last amazingly long? Yeah, they do. I mean, they last amazingly long. Drag and drive events, you know, if the tune-up's good, really last a long time. Surprisingly so. And but if you over rev them, if you put it on a rev limiter, they're going to hurt stuff. Period. Rev limiters, high-end rev limiter, not the two-step rev limiter. High-end rev limiters kill everything. I don't care what it is. It's going to kill parts. But in general, this is a shock absorber. We need this cross-sectional area to be strong enough to take it. We need the aluminum material in order to be like a little shock absorber that absorbs a lot of stuff that a titanium rod would just put right into the bearing and hurt. So that's why.
And what do the top fuel guys with unlimited money use?
Could they afford to put titanium rods in it? Absolutely. Do they? Nope. The 12,000 horsepower engine with unlimited funds and money doesn't use titanium connecting rods. Wonder why that is. Oh, Clay Milliken watches me occasionally. Answer it, Clay. Answer the question. All right, let's pop the valves out. This is the driver's side pin. Okay. It has one little bad valve seal. No big deal. Grand scheme of life, doesn't matter. All right. That looks fine. The valve guides felt good. Let's take a look at the valve job here. Now, without getting real involved, and we're just looking for any kind of defects, anything funny here. You can see the pattern where the valve is making contact with the valve seat. If you can see that. See the shiny, I don't think you're in the light. I can't tell. See the little dull right there on my fingernail? Shiny below it, shiny above it. That's where the seat is riding. That doesn't look bad. The guides don't look bad, like I said. All right, that looks fine. Let's get this other head all apart here, the passenger side, and then we'll go run these springs real quick. Now, looking at the valve, see, this is where good input from the customer always helps. Once again, if Garrett didn't tell me of what he had done, I would look at this and just go, looks perfectly normal. I'd measure everything up here. I know where, everything from the valve lash was, what everything was all at. There very well may not be anything wrong with this valve. But given that this was at 1700 plus degrees for a relatively extended amount of time, but keep in mind, usually 1700 degrees, if ever hit on, especially in methanol, if ever hit, only be happening for 4 seconds or so. So when he's literally running it there for 30 seconds or a minute, however long it was there, I mean, it's like a lot. Think about how you hit something with a torch and you go like that. You already hit this valve with a torch like that. It doesn't get very hot. Hold it there for 30 seconds. There's nothing there. So the longer it is, the more damage it does. But I probably won't find anything wrong with this. But given what happened to it, I'm just going to replace them. Intake valves shouldn't be any problem at all. They're a really nice titanium valve. They don't get the heat from it. Looks nice. Looks good. Yeah. I don't think there's nothing going on there. Looks great. So let's get this other head apart, go over there, check out the springs. And then remember, like you guys, if you guys have questions, feel free to ask them, put them in the comments down below, whatever, because I'm going to start from the first one and then just keep on working my way up until I see some questions or some kind of question and I go, that's a really good question. And then I'm going to come back on Thursday's video, answer that question, and whoever I answered that question for, is going to get a box of swag. Going to send it out. All right. So let's get this one apart. F1.
Press it.
Huh? Test it, and then I gotta hit F1 again.
Now the time's going.
All right. So we're testing springs here. Joe's showing me how to do it because I usually make him do it. All right.
You see how it's kind of weird up there?
Yeah.
Now you can do the next one.
Do you have to hit F1?
Yep, every time.
Every time.
And you'll know when the timer starts that it's gonna record it.
All right. So showing you top secret information here. All right, so here we look at it. What's the, you look at the data, Joe. Which one do you push?
Oh, right.
Bam! Bang! All right, so we have a spread. The spread number is right because I think my seated height is wrong. But a spread of 20 pounds, which is acceptable. And because I think that the actual installed height on this is 2050, not 2100. That's all right. And bind height, clearance, yeah, because I know that we're closer to that on our coil bind height. So, long story short, valve springs look pretty good. So all things said and done, we had one bad valve seal and
Thrust bearing.
Thrust bearing. That's it. And questionable exhaust valves only because of what they went through. So all things said and done, that's a pretty good deal. I think we're just gonna start working on this thing. Got to put the rollerized thrust bearing in it for cleat, and gonna get some valves for this thing. I think we'll put new springs on it too, just for kicks and giggles. Already had new retainers on it this last time. All these valves were new last time too, but that's all right. We're not gonna have to replace or do anything with the intake valves, but we are gonna replace those exhaust valves. And rollerized thrust rings. Not going to put bearings in it except for a thrust bearing. Actually, I might not even put that thrust bearing in there, because one of the things that we do is to make sure that it only hits the rollerized portion of the thrust bearing. I actually sand down the back side of the thrust. It's pre-sanded. How about that? So I think we'll just tune that up and do that. So all things looking pretty good. Leave your comments. Make sure you hit the like button and subscribe if you're not subscribed, and come back for more. Got a really good video coming up on Tom Bailey's SMX where it actually broke the head of the valve off. Well, it was a 2.5-year-old valve that hit the rev limiter more times than it made a pass.
Not good.
Yeah. So anyways, and showing you how I fixed the chamber because this thing dropped a valve and just destroyed everything. It looks like brand freaking new. Can't even tell. It's really amazing. So come back on Thursday and I'll show you all that stuff. I'm Steve Morris. Have a great day.